Hello, everyone. Thank you for joining the webinar organized by the Horizon Project, DIGISOLAR and SUN-DT. I'm Céline Suchet, Communications Manager and in charge of the communication activities of the DIGISOLAR project. I will be accompanied by Konstantinos Genikomsakis, Product Manager and responsible for the SUN-DT communications activities, who will moderate the chat and also the Q&A. So let me quickly walk you through the agenda. Before starting the presentation, we will ask you a few questions to understand your knowledge and needs of the solar thermal sector. We will then have a first presentation of the SUN-DT project that will be followed by an introduction of the DIGISOLAR project. Two partners of DIGISOLAR will also present you two of the tools developed as part of the project. And after the presentations, we'll dedicate some time for the Q&A. So before we begin, a quick note, all online participants are automatically muted. So we invite you to use the Q&A section to ask your questions. When submitting, please be sure to address your questions to the relevant speakers. This will help us keep the discussion smooth and organized. The recording and presentations will be shared by email to all registered participants, and we will also publish them on the project's website. So now we will start with a few questions. So we invite you to scan the QR code that you see on the slide, or you can also go to slido.com and enter the code that you see on the slide. So now you should be able to see the first question. And we invite you to, yes, I see that some people are already online. Great. For the moment, we see that performance optimization has the highest score, then operation and control, and digital twins and simulation. Now we have operation and control and performance optimization, and then digital twins and simulation. So for the participants who have joined us, we invite you to scan the QR code that you see on the slide to participate in this poll, or you can also go to slido.com and enter the code that you see also on the slide. Okay, so now we will go to the second question. So do you consider solar thermal technology for industrial heating and or district heating projects? So yes, for industrial heating, yes, for district heating, yes, for both, or no, we don't currently consider it. So for the moment, it's clear that it's considered for both. Okay, so now we will go to the third question. So when using solar thermal, which technologies do you generally hybridize it with? So heat pumps, photovoltaics, biomass, photovoltaic thermal, gas burners, or we do not hybridize. So, so we have a majority of photovoltaics, heat pumps, gas burners, and also a bit of photovoltaic thermal. Thank you for participating in this poll. So now I will invite Marcelino Sanchez to present the SUN-DT project.
Okay, thank you very much. Okay, thank you for inviting me to this webinar. Okay, I want to talk about solar energy, of course, and digitalization. I want to share with you my view about solar energy and what digitalization can do for it. And also I will present the SUN-DT project. So I titled the presentation CSP 4.0, the era of intelligent solar energy. So before talking about digitalization, I want to share my view about solar energy. If we compare we view the history of the humanity, the solar fields only represents just a candle in the dark. We start to have a massive consumption of solar fuels after the industrial revolution, and we are reaching the end. But on the contrary, solar energy is going to be here for billions of years. So I really believe that solar energy is not just a choice; it's the only possible choice that we can do. We have to use it in the best way, and we have to preserve it. Okay, so this is just something to think about. And then, yeah, the next is about why it's very important today to have an intelligent use of solar energy. As you know, we are facing the energy transition. This is difficult. It's not something that easy. So we need to include this complex system in the grid, which also is complex. We have this blackout in Spain, so we want to avoid this. So we need an intelligent integration of these technologies in the grid. Also, we have now artificial intelligence, digital twins, and analytics that these tools can help us to improve the performance of the plants, and also to improve the performance of the whole grid and the energy system. So I believe that CSP, regarding its degree of complexity, is an ideal testbed to perform this transformation and to help the energy system to become más effective and to pave the way for the energy transition. For those that are not familiar with CSP, I want to explain what is CSP. In CSP, what we do, we concentrate the energy of the sunlight from and we transform this in high temperature heat. With this heat, we can convert it into electricity, or we can use it for process heat, or even for green hydrogen. And we can also store this energy in thermal storage, and we can have dispatchable renewable energy. That is an advantage of this technology. So I really believe that this technology should play a key role in industrial decarbonization, in energy transition, and in the future sustainable energy systems. Why we believe that solar towers are the technology that have more potential? Well, this is due to its features. In solar towers, we have higher concentration ratios, that this allowed us to have also higher temperatures, and with higher temperatures we have two things: high conversion efficiency and also a better energy storage. In the case of the energy storage, we can store much more kilowatt hours at high temperature with the same volume, with the same, let's say, capital cost. And we have also this energy storage, we have low cost and massive energy storage, that in our case, we are using molten salts mainly, and other materials. We are using environmentally friendly storage systems. And we can dispatch electricity during day and night. What is the strategic value of CSP systems? We can provide the grid flexibility with the storage, but also reliability. I want to emphasize that we are using synchronous generation in the same way that any other power plant, nuclear power plant, and also carbon plants. So we are providing the same kind of quality of electricity to the grid. And as I already told you, we are using high temperature for industrial heat. Okay, we can produce hydrogen, and we have this environmentally friendly storage. So CSP tower is a unique technology that combines renewable generation with large-scale energy storage, which is critical for the energy transition. Okay. Why I believe that CSP is a good digitalization testbed? The solar towers are very complex. We have many heliostats, thousands of heliostats. We have to deal with thermal and optical interaction. We have to control this in a dynamic way. We have plants that are very data intensive with multi-physics. So we require advancing senses, artificial intelligence prediction, digital twins, and real-time analytics. If it works for CSP, it can work for any other energy system to be integrated in the energy transition. With digitalization, we are going to have a smarter operation, lower operational maintenance cost, higher reliability, better grid integration. We can provide industrial decarbonization, and in general, we can have a smarter energy transition. Well, for me, digitalization. Digitalization is not only about handling data or even making digital twins. It's about having 3 layers. For me, one layer is measurement, monitoring. We need to have better sensors, better monitoring of the plant. We need to know how the plant is at every moment. We also need the modeling to have this physical and performance model, the digital twins, and also the degradation model. And finally, we have the decision making with all this information of to take decisions that we can have machine learning or even predictive operational maintenance, or also to dispatch the energy to optimize the dispatchability of the energy to the grid. So to me, this the value of this decision comes from the integration of all these layers. Now, I'm going to talk about the project. The SUN-DT project is the smart use of novel digital tools for advanced performance and reduce cost in CSP power plants. In this project, we are 9 partners. 5 partners out of these 9 are technological centers. 3 of them are devoted, or the background is energy, like India Energy, ourselves, Tener or Dealer. Our background is mainly energy. We have also 2 partners that are more, the background are more related to digitalization. It's India Networks, and in this case, TMAT, because we are working with TMAT, the group of digitalization. Okay, we have also 3 companies, Cox Energy, Acciona, and Inavitas. Cox Energy and Acciona, their background is an energy background, but Inavitas, their background is digitalization. And we have also Stella, that is European Association for Solar Energy, that is working in the same mission. What is the objective of this project? Because the objective is to improve the performance, reduce the operational maintenance costs, and enable a smarter plant operation. In this project, we develop the smart use of novel digital tools. We have advanced measurement and calibration tools in the project. We have also a digital tool of the solar field and the receiver. We have an energy management system, and we have also predictive operation and maintenance tools. If I'm going a little bit more to the detail, we have these 4 digital tools. One is devoted to the quality control of the heliostat and the calibration of the heliostat field, but for each heliostat, this is the tool that we call Heliostat. Then we have other tool that is more devoted to the digital twin and the control of the whole heliostat field and the receiver, and to control the flux maps on the receiver. This is an image of the flux map, and these are some images how we control the heliostats. Then we have other tool that is regarding the energy management system to optimize the dispatch to the grid. So in this tool, we have as input the meteorological data and also the needs from the grid, and from that we optimize the operation of the plant. And in addition to this, we have another tool that is more devoted to predictive operation and maintenance, to the daily needs of the maintenance of the people that are making the operation and the maintenance in the plant. Okay, we have from this the predictive and corrective actions. What is our methodology in this project has been designed with the idea of making a real technology transfer to the industry. So we have been working together with this industry from the very beginning. Together we have defined the digital tools that we believe are more useful to the industry and to the real needs of the technology. Are the 4 that I already mentioned before, and also they are all integrated in a common platform where all these tools are integrated. I forget to mention before. These tools are going to be tested and operated first in 2 experimental test facilities, one in Madrid and another in Jülich. In Jülich, okay, this belongs to India Energy, and this belongs to DLR. So once these tools have been tested, integrated and validated, they will be delivered to the industry, and also the tools, to some extension, will be tested in real commercial power plants. So this is the scheme of the project. Then what are the expected results? We expect to increase the overall plant efficiency between 4 to 10%. This will come from the efficiency of the heliostat field and the receiver. We are going to improve this. Also, we're going to have fewer faults thanks to predictive maintenance, and also less unplanned downtime. Okay. We also believe we are going to have at least an improvement of the annual output in 5% due to the more availability of the solar field, and also an increase in the thermal output of the plant. In addition to this, we expect to have a reduction in the OPEX in about 15% due to the automatization of the tasks to be done in the field and to reduce of the human error, also to the predictive control and operation modes, and to the reduced need of corrective maintenance. And also reducing capex, because with the optimized design, we believe that we will not need to oversize the solar field as we are doing nowadays. What are the challenges or some opportunities? One is the cybersecurity. You know that today is very important. You want to avoid to have any cyber attack in the plants. Also, we were going to, at the beginning, include digitalization, includes an increment in the cost, in the capital cost, and we need regulation and collaboration. What are the opportunities? New data-driven business models. We are going to have digital tools that are going to improve the design and optimization of the plant, and also we're going to have a better reliability and performance of the plant. Then also, if I think about digitalization, not only in solar, but in the future, I think it's a very important opportunity, because we're going to shift from the model that we have today, that is a monodirectional model, to a model where we have not only producers, but also prosumers, people that consume and produce electricity, energy. We are going to have real data, which give us the opportunity or the availability to play with the energy generation and the storage. We can have a greater transparency of the energy you are using. For instance, as consumers, you could choose which technology you want to use and why, and also we will be informed to have energy decisions. So it will give us the opportunity to have a better grid management and also a shared responsibility with our energy system. The conclusions, okay, CSP plus digitalization give us a better, intelligent way of using renewable energy and integrate these energies in the system. Digitalization is transforming renewable energy system, is transforming our society. CSP is, from my point of view, an ideal platform for artificial intelligence, digital twins, and advanced analytics to be applied and tested on field. Solar towers provides renewable electricity at large scale storage, and we can have grid flexibility and industrial decarbonization. And with our project, with SUN-DT, we are pretending to demonstrate how intelligent tools can improve efficiency, reliability, and competitiveness in a real environment. And finally, I really believe that the future energy system needs renewable assets that are clean, dispatchable, and intelligent. And through artificial intelligence, digital twins, and advanced analytics, our project SUN-DT is helping solar towers to evolve towards that vision. Okay, thank you very much for your attention. If you want to see more information on the project, you can find it in this here. Okay, thanks.
Thank you, Marcelino, for the presentation of the SUN-DT project. So as I mentioned before, we will address all your questions during the Q&A session. So please use the Q&A chat, the Q&A section, sorry, of the webinar, and we will address them later after the presentations. So thank you, Marcelino.
Thank you.
Thank you. Now I give the floor to Xavier for the presentation of DIGISOLAR.
Hello, everybody. My name is Xavier Chico. I am the Chief Technical Officer at DICARBO, and at DICARBO we are coordinating the DIGISOLAR project. As you can see, This project has many similarities with our sister project SUN-DT in the sense that we are trying to use data to improve the impact of the solar technology. In this case, we are developing advanced digital tools for optimized planning, maintenance, and operation of solar thermal hybrid systems. Solar thermal in the sense that we are using collectors to produce low-grade heat, let's say, to differentiate it to the concentrated solar power that Marcelino was discussing before. And I would like to underline the word hybrid. Hybrid in the sense that we believe that DIGISOLAR, the aim of DIGISOLAR is to incorporate digital tools to hybridize easily solar thermal fields to increase their impact in the market, as we will see during this presentation in the next 10 minutes. As we said before, DIGISOLAR is a European project, but it's also funded by the Swiss government. It's a budget of around 6 million euros. It will end at the end of summer of 2029. We are 11 partners from 7 different countries. We are developing softwares, and we are going to develop them up to TRL of 7, and we will demonstrate those functionalities of the software in 4 different pilot plants. Before going forward with this introduction to the DIGISOLAR, I would like to share with you this nice video that our colleagues of communication and dissemination has produced for the project. And I think I did not share correctly my screen, so let me do it again, because I have to include the sound. Even if you try and you test these presentations, you always forget to do it when you have to. So now we are here, and as I said, I will share with you this video that explains nicely what DIGISOLAR is about.
Europe is racing toward a sustainable future to achieve climate neutrality by 2050. Solar thermal plays a pivotal role in this transition, offering a local and reliable supply chain that reduces greenhouse gas emissions. To unlock higher renewable fractions and greater flexibility, solar thermal can be combined with complementary technologies like biomass, heat pumps, photovoltaic systems, and power to heat. The DIGISOLAR project envisions a future where this hybridization, driven by advanced digital solutions, becomes a key pathway to deep decarbonization. Digital technologies offer quality assurance, optimize operational efficiency, and maximize clean energy generation. At the heart of the project is the DS Suite, a digital platform using AI, digital twins, and predictive control. This framework features 5 interconnected tools designed for the planning, operation, and optimization of large-scale hybrid solar thermal systems. By providing transparent data, these tools build trust, accelerate decarbonization, and enhance performance for industrial processes and district heating networks. To prove its impact, the DS Suite will be deployed across 4 operational plants in Turkey, Italy, Germany, and Greece, utilizing parabolic trough collectors, flat plate collectors, and high vacuum flat plate collectors. This implementation will enable advanced planning, real-time monitoring, and operational optimization. DIGISOLAR will transform Europe's energy future, cutting risks, costs, and accelerating solar thermal adoption.
Okay, so after this nice video, I will try to get into slightly more technical level about what we are developing in this project, in DIGISOLAR. At the aim, and in the center of the project, we have the DS suite, the DigiSolar software suite, that is going to interrelate five different tools. As you can see, we have some similarities here with our sister project SUN-DT. We are developing different tools that we will explain briefly now. And my colleagues, Damien and Marnok and Damien, will explain in more detail two of the tools, PyTransit Suite and SunPeak, for the audience to understand what the digitalization is going to produce. The point of the DS Suite is to support planning, operation, and optimization of large-scale hybrid solar thermal systems. As we said, this is also the point of the project, and we believe that by the hybridization of solar thermal systems and digital tools, we can indeed foster the adoption of solar thermal systems by industry and district heatings, increasing their shares of renewable in our society. One by one, as I said before, PyTransit Suite will be explained by Damien in more detail, but just to quote it here, PyTransit Suite is an all-in-one harmonized planning to digital twin at system level. It means it is a tool by running transits in its core. One can produce pre-designs, feasibility analysis, basic engineering, detailed engineering, and all that work in the building or in the construction of the hybrid solar thermal system can be also reused to produce a digital twin at the very end that helps us to understand what's happening in the plant, and then, of course, improving its operation and maintenance. SunPeak, Marnok will provide us some details about the tool and the developments that are expected within the DigiSolar project, but it is a tool that is already existing and it will be improved along our project, and it's meant to produce performance verification of solar thermal fields following standards. And then it's a tool that is very valuable because it can be connected to other tools that are also being developed in this project. In this case, we have a module that is responsible for the fault detection and diagnosis of different faults not only in the solar field, as is the case that we are showing now, but also in the whole system. By using machine learning techniques, our colleagues from Third in Greece will produce algorithms that are using or reusing data from other tools, will be able to detect faults, diagnose them, and even we are expecting to forecast those faults, and we want to use that information to assist or to support some predictive maintenance. There is also a fourth module for software that also will be included in the DS Suite, which is an advanced energy management system, which basically will help two things. At the design level, we will help combining different hybridization renewable sources to produce optimal designs, and also when the plant and the system is built and we have storages, power to heat pumps, or other renewable sources combined with our solar thermal field, the software is going to produce an optimal dispatch, helping to reach optimals in CO2 decarbonization or optimal costs by combining all these sources. Finally, we also have a fifth tool, which is Verify, which is a tool that produces a real-time life cycle analysis and life cycle cost KPIs, and is a tool that will be connected to the emissions trading system. And we believe it is a tool that produces very interesting information and data for the solar thermal owners, as it helps quantify the positive impact on the environment that is produced by their systems, and it can also prove it by following standards ISO 14040 and 14044, which gives a lot of credibility to these installations. As we said before, as I said myself and also in the video, we are going to demonstrate this software in 4 different real facilities. First one is a district heating in the north of Italy with a 0.7 megawatt collector area using high vacuum flat plate collectors. There is another big installation, pulp and paper mill in Turkey, which is using a parabolic trough collectors technology, so increasing slightly the temperature, and it's producing 3.5 megawatt thermal. There's a third installation in Germany, a very large 20 megawatt flat plate collector field that is feeding food processing and a district heating in the neighborhood. And finally, there is a pulp and paper mill in Greece that is being built as we speak, that is going to combine a high vacuum flat plate collector solar field together with heat pump. Both they will work together using the advanced energy management system of DIGISOLAR to produce heat, and this heat is going to be, of course, utilized by the mill to produce paper. So again, thank you everybody for listening to this short introduction about DIGISOLAR. Now my colleagues Marnok and Damien, we will present with more technical detail 2 of the tools that will compose the TS suite, and I hope you will find it very interesting. If you have any question, of course, we will be very, very glad to answer it later on in the Q&A session. Thank you.
Thank you, Xavier. Now, Marnok, I will ask you to share your presentation.
Right, yes. As Xavier and Selena already mentioned, I'm going to give you a little bit more detail on the SUN-DT tool, which forms part of the DS suite that we're building in the DIGISOLAR project. SUN-DT is a performance monitoring tool for large solar thermal collector arrays. The key point about SUN-DT is to provide standards-backed performance verification and monitoring for solar thermal plants in a way that is robust and transparent and trustworthy. I've mentioned these 2 phrases already. SUN-DT is focused on the operational phase of solar thermal plants. So there are a number of tools out there for the design phase, including ones that are included in the DIGISOLAR project. We are focused on the post-design phase, on the operational phase, enabled by the ISO 24194 standard that came out a few years ago. And we aim to do 2 things during that phase. We aim to do performance verification, which is a sort of, think of it as a one-off check that the plant performs as well as expected, and performance monitoring, which is an ongoing process to see how the performance of the plant evolves over time, which can potentially be used to detect slowly evolving faults and performance anomalies and rectify those. Very quickly, how it works. We take the measurement data, so the actual performance of a solar thermal array, and we compare that with the expected performance computed using a physical model that is given by the standard. And the important thing about that is that the actual performance that the expected performance, excuse me, that we compute takes into account the actual radiation, the ambient temperature, the flow and return temperatures from the rest of the system, all of which affect the performance of solar thermal plants. So the result we come up with, the expected value we come up with, is the value that can be expected from those particular collectors under the conditions they're actually seeing. Which means that if the measured value that is returned is not relatively close to that, then we know that something else is going on that is related to the collectors themselves. SUN-DT is very much focused on the collector field. So we can evaluate whether the collector field is performing normally given the operating conditions it's in. Those are affected by the rest of the system, which SUN-peak does not evaluate. And there are other tools in the DS suite, for example, PyTransys, which Damien is going to present after me, which addresses the wider system. So I mentioned monitoring. The key thing about monitoring is that we can do repeatable long-term tests of the performance of the collector field, and that means we can spot slow-moving decays in performance. This is an example from an open data set that we have from a plant in Graz in Austria, where you can see the performance is gradually degrading over time, and this would be very hard to spot if you just looked at the production data every day in a spreadsheet or whatever. But when we assess it like this against the actual expected performance, what we see is that the performance degrades gradually over time. The operator went out and cleaned the surface of the collectors, and the performance immediately jumps back up to where it would be expected to be. I will get into this a bit more later, but this is something that we are exploring more in the DS suite. Very quickly, SUN-peak is designed to integrate with the existing implementation and be very quick to set up for solar thermal plants as they are actually built and instrumented in the real world. In order to add a plant, you put in some metadata like the location, put in the type of collectors that are in use, that is very relevant. Configure the measurement channels, so map the raw data channels that are configured in the SCADA system or whatever data acquisition system exists at the plant, and map those to specific semantically meaningful data channels within the software, and then upload some data, set some safety factors which depend on a few other things, and get a result. This is designed to be a very quick tool to use on a very wide range of solar thermal field configurations. This is one example configuration, and this is the sensor configuration that you would need for this setup. These are sensors that exist in the vast majority of fields that are configured like this, because they're generally required for the control system anyway. So that's what SUN-peak does at the moment. As part of DIGISOLAR, we are building the DS suite, as Xavier mentioned, and SUN-peak will be integrated as a core component of that, and also we will be adding functionality to SUN-peak to enhance the capabilities of the whole suite, make it work better with the rest of the tooling. I mentioned this already, so we can detect slow-moving performance anomalies based on what you see here, which I already described. We will, at the moment, this detection is based on a visual inspection of a graph like this. We will be adding methods to explicitly programmatically flag these kind of events. And those anomaly flags can then be passed to the fault detection diagnosis tooling, which is being built elsewhere in the project to enhance its accuracy and capabilities. And so we can, this is the real advantage of this project, is integrating all of this tooling together to form one coherent system. We are also going to be implementing a dynamic performance assessment method. This is somewhat an extension of what exists from the ISO standard, which is a static assessment method. There are strict filtering criteria in the standard to pick the time periods that provide relatively stable operating conditions. The dynamic method will allow assessment during less stable operating conditions, which gives us more time periods when we can do these analyses, and that should allow detection of performance issues sooner. present, don't worry, I won't go into too much detail on this slide, it's quite technical. At present, we have a very robust data ingestion process where we parse incoming data, calculate what we call virtual sensors, so calculated parameters based on our measurement data. And we also do what we call context-aware data validation and data cleaning, which means, for example, that an ambient temperature sensor that's reading 70 degrees Celsius, even this week, that would clearly not be a valid ambient temperature sensor value, and so we can remove those values that are clearly invalid based on known context about the sensors. As part of the DIGISOLAR project, we're going to be moving that functionality into a new data management platform, which will form a core component of the DS suite. And that will be the central time series data storage and data management component for the suite. And that will make that functionality available for all of the other tools in the suite to leverage. That's everything from me. I think everybody else has mentioned we're funded by the European Union under Horizon project. Thank you very much. I'll pass you back to Celine.
Thank you, Manok. So as I mentioned before, I will just ask the participants to add your questions in the Q&A box, and we will address them after the last presentation. So now we can go to Damien.
I'm excited to present to you the second tool that we're going to present today of the DS suite, which is itself a suite. We call it the PyTransit suite. It is the all-in-one harmonized planning to digital twin framework. That's our nice marketing term. It's a web-based tool, reliable tool. Ideally, once it's finished, it should be investor trusted as well, like help you finance your projects. And one of the key distinctions of the tool is that, or one of the, let's say, key benefits we believe of the tool is that it's applicable across all project phases. So from pre-feasibility studies through the design phase, through then in the end, even the operational phase. And one reason why that's the case is that it uses the same computational engine throughout the project phases, and that the engine is called PyTransit, and some of you might be familiar with the transits in PyTransit. So at the very core, the computational engine is Transit, which is already quite widely used in the industry. So it already brings with it some history and some trust and some validated model and so forth. And within the DIGISOLAR suite, the PyTransit suite is connecting to other tools, of course. I mean, they're all integrated together into the DIGISOLAR suite. In particular, the fault detection and diagnosis tool will be using data or simulation results or the mismatch between the two from the PyTransit suite. And also the models within the PyTransit suite, the PyTransit models or the Transit models are used to validate the model predictive control or / the advanced energy management system tool, which is also in here under real-time optimization MPC for systems operations. Right, here we see again the three different phases that our tool aims to support. And you see that the kind of the feasibility or pre-design phase and the design phase are currently under development, and the whole, let's say, digital twin operation phase part will be still developed within the DIGISOLAR project. And the feasibility pre-design part is, as I've said already, is an online tool. It runs in the cloud. You can access it with your web browser. It should be easy to use. At this stage, you cannot change your system. You cannot change the hydraulic connections and so forth. But you kind of pick a predefined configuration for a system, and change the parameters for your pre-feasibility study. Like, I mean, the relevant ones, like your storage size, like your collector field size, like your collector type, etc. So you don't need to model yourself. You pick a pre-configured model and input the parameters and run. And the simulation will be run in the background in the cloud using the PyTransit suite. And then once you want to transition, well, maybe I'll go into the actually individual phases more in detail, but let's go one by one. So, I mean, here you can see a bit more graphically kind of what the tool looks like. So on the left, so the pre-designed feasibility tool on the left-hand side, you see the kind of input mask with well, some parameters as an example that you can input here, and then on the right-hand side, you get, at the moment, you get nice plots. For example, energy balance plots or state of charge of storages, etc. We will be adding further KPIs as well, more on the kind of a report side. So now let's go to the design phase, where we're using, or where you as a user can also use the PyTransit tool, which is used in the background for the feasibility phase. But you can, when you move from the feasibility phase to the design phase, you can export the PyTransit project, download it to your computer, and use it there. And there you have the complete flexibility. You can change the control. You can add additional hydraulic connections. You can do whatever you want. At this point, I have to say a Transit license will be needed because you'll be running the simulations locally on your computer, and for that Transit is needed. Kind of, some of you might know that kind of the default Transit license is quite expensive, but there are also talks with the Transit people about limited licenses and so on, but this is still all very much in progress. So what does the GUI look like? I mean, it really looks, it's running locally on your computer. Actually, I have started up here just to write. I mean, you will, I mean, when you export this project from the web UI, you will get such a system, but you can also then, I don't know, introduce, maybe you have an air source heat pump somewhere in there as well. You can introduce that and then change your system accordingly. Now I need to share again, I think. Oops. Yes. And then, well, this tool will just, I mean, the PyTransit GUI will just spit out a huge text file, which is kind of looks like this. Not really meant for human consumption, but this is then the input for the Transit computational kernel, which will run the simulation for you and produce the results. And then finally, in the operation phase, where the PyTransit suite will take the models from the previous phases and kind of turn them into a digital twin, connect them, run it in the cloud, connect them with real data coming in from the plants, and do performance evaluations. But as this tool hasn't yet been developed, or no development has been conducted so far, I can't really show you anything there at the moment. Yeah, so then the pre-feasibility UI interface is actually already online. You can register to get an account, and if you're interested, if you're planning to do that, get in contact with me, because you need a registration code. And once you've registered, you can log in with your username, play around with it, I don't know, change the relevant parameters, run a simulation, wait for a while. You'll see the progress. You also see an estimated time for when it's done. You can come back to it later. And once the simulation has finished, you can look at the current result visualization that we have. But I have to say that this is still very much a work in progress. So expect some things not to work. Also, don't. I mean, your data will at some point probably delete it. Yes. So I mean, it's really just to poke around with. Don't use it for your project yet. So what are we going to do within DigiSolar? We'll be adding new systems on the one hand. So three systems based on the plants which are included in the project, and we're going to do this for the plant in Turkey, in Germany, and in Greece. And also we'll be adding 5 kind of representative big systems representative of commercial hybrid solar thermal systems. You think of them as a template. These probably will be used in a pre-feasibility study, and then maybe kind of downloaded locally and adjusted to your actual project. And then so we have the new systems that we're going to do. We also will add new functionality to the Pattern Suite. And this new functionality is all to do with the operation phase. So that will be the whole digital twin concept. And of course, there we need to connect to the plant, compute the expected KPIs based on simulations, and compare them to the actual KPIs based on measurement data, and do this continuously. I don't know, every day, every hour, every month, well, maybe every week, things like that. And then, for example, kind of flag this to the fault detection or flag the difference to the fault detection and diagnosis tool in the suite. Yes, and as I've already mentioned, also will be kind of used to validate model predictive control and an advanced energy management system. I'm not going to mention the funding again, but we're of course very grateful to our funders. Yes, and that would be the end of my presentations. We will take questions at the end. And here's my email address if you want to get the registration code for having a look at the Pattern Suite at its current stage. Thank you very much.
Thank you, Damien. So thank you to all the presenters for presenting and introducing the SUN-DT and DIGISOLAR project. So now we will take the time to answer your questions. So you can use the Q&A box, and please just mention the name of the presenter. So Konstantinos, maybe could you please check the Q&A box and share the questions with the presenters?
Yes, thank you, Celine. First of all, to introduce myself, I'm Konstantinos Genikomsakis from Estella, the European Solar Thermal Electricity Association. Estella is the partner leading the communication and dissemination activities in the SUN-DT project. And as you already said, my role today is to moderate the Q&A part of our webinar today. We had one question so far from Maximilian Bayer. Sorry if I don't pronounce well the name. It was addressed to Javier. What is P-Transis suite? Is that the tool which was used for planning?
Yes. Well, as we have seen, later on during the presentation, Damien explained it properly. I don't know if you, Damien, do you want to take the answer of this question? I think that you will answer better than myself. I will just do the headline. Yes, P-Transis suite is a tool that can be used for planning, but also for basic and detailed engineering. And finally, it will produce a digital twin, which will be also used for operation of the plant. So if you want to give more details, Damien, thank you.
I mean, I don't know what I could add to your answer. Perfect answer.
You know more than myself. I don't know. Maybe you can give details about how it's the stage of the planning, or how many types of systems do you plan to plan with the P-Transis suite? These typical systems. Maybe you can give us some more detail about it.
Yes. Share again. So the yeah. Am I? No. So now I'm presenting, but I'm not sharing. Yes. So yeah, as you said, it kind of covers almost the whole project life cycle. But I would say it's quite heavy on the planning, say feasibility, and then design phase. So kind of planning historically also it was in that corner. But we will add this third pillar, which is kind of monitoring / digital twin, to actually connect the planning phases to the operation phases. And kind of maybe what you alluded to, Xavi, was that we're going to add these 5, so the number is 5 kind of representative models that even though the models are fixed, we will try and pick them to be a good starting point for people to take them to be usable in the pre-feasibility study for their potential project, and then also to be used as a starting point that people then can modify in the design phase within the PyTransit GUI, so the local tool into which they export the project from the online user interface. I hope that answered the question.
Thank you, Damian, for elaborating more on the PyTransit tool. I don't see any other question in the Q&A box, but I would like to take this opportunity to start making questions to all the presenters, hoping that this will trigger also the interaction from the audience. I would like to start with Marcelino from TENER and the SUN-DT project. So, Marcelino, a key, let's say, commitment and deliverable of the SUN-DT project is about the integration of the tools, which we are talking about heliostat calibration, optimization, receiver optimization, dispatch optimization, predictive operation and maintenance, all these tools under one platform. My question here is, can we already talk about additional benefits or decisions that become possible by bringing all these tools together, rather than having them as standalone tools? And so the question is, can we already say about potential synergies and more benefits, or we should wait for the demonstrators at our 4 sites?
And of course, we'll have additional benefits, but it's difficult to explain here the complexity of the project. In this project, we are going not on, as I already explained, the tools, the four digital tools that are afterward integrated in the platform. Each of them also include new instrumentation, monitoring. So we are developing a lot of things. These tools have already developed and at different level at lab scale or in some prototypes. So we are not starting from scratch. But now we want first to demonstrate them in a relevant environment in the sites at INDEA and HILIS that are operational sites with a relevant size. And afterwards in the commercial plants in Cerro de Mirador and DIGISOLAR. So even just putting these 4 tools in let's say on field will be challenging, but we are confident because we have previous experiences. So we are not starting from scratch. Now, the integrated them in the platform. The idea is to have a platform that will have information of all of them, the relevant information, and also we could, but at this moment is premature to say, to have some interaction between the tools through the platform. So some key decisions could be done in this way. But at this moment, we are very much focused in developing the tools. We have been, as I told in the presentation very briefly, we have been discussing the details of the specifications of the tools to be practical for the real commercial sites. The tools have been adapted. We have 2 commercial sites here, but the sites have not been instrumented in the same way. They do not have the same, let's say, hardware. So we need to adapt this to be sure that we are really fulfilling the requirement of the sites. And even we have now written down agreements of transferring the technology to the plants. So what means that our goal at the end of the project is that these tools are going to be implemented, and going to the companies are willing also to let's say to install these tools in the plant, because as you know, solar towers are facing in some cases some problems of especially of reliability, and we want to avoid this. So I don't know if I explained, I answered you, but at this moment our main goal is not just to have a smart platform to integrate the tools, but to have a platform that integrates the tools, and is the first step. We are now much more focused in having the 4 tools up and running and demonstrated first in these experimental sites, and after in the power plants. Okay, but then, yes, the platform will be designed and developed in such a way that could be used as a smart platform in the future, but this is not our main goal in the short term. Okay.
Clear. Thank you for your answer. I would like to follow up though, since we know that for commercial CSP plant owners or operators, the key question is often linked to risks related to downtime, underperformance, uncertainty in operation and maintenance costs. So where do you see the SUN-DT project to creating highest value for existing plants or new projects, new plants that are under planning or development?
Yeah, I know this is a tricky question. I mean, the question is today in the world, as you know very well, we are not in the world the only country that really, well, there are two countries that are now promoting new plants. One is Mexico, that has a real, let's say, recent announcement of new plants, but they are starting with 2 plants. Now, in the rest of the Occidental world, we do not have new plants for at this moment. Spain has said that we will install plants, but this, well, it's true that this in the plans, but it's not clear that it's going to happen. At least we are talking to the ministry, and I do not see this to happen in the near future. But we have the people from China that they are really willing to they have already installed a lot of gigawatts, are going to install even more. They make an announcement few months ago. We are also in contact with them. Okay, but this is, as you know, a tricky relationship also. But yes, what I believe is that these tools are going first to be, or I hope to be tested in these 2 commercial plants, Renewable and DIGISOLAR, that are from 2 different companies, and if they work, this world is small. If they work properly, they will be easily known by everyone. We know that the Chinese people that they are installing plants, they also want to include digitalisation and new instrumentation in their plants, and we are also in contact with them, but of course not through an European project. And yeah, the idea is, if we succeed with this plan, I hope 2 things. One is that these tools will be incorporated in the new plants also in Mexico. In fact, I'm going to have a web meeting with Mexican people tomorrow evening. And hopefully this will help to, let's say, to start or facilitate the implementation of additional plants in Europe. Okay, because yeah, and this is what I hope. Okay,
this is what we need. Thank you, Bartolino, for sharing your insights. It's really important to have these things be heard. And I would like to jump now to the Q&A box again. We have some questions. I think these are related to the DIGISOLAR project. The question is, which tool has been used to optimize the flow in the solar thermal system? Is there any thermal analysis performed? I don't know if Javier would like to go first, and then possibly forward the question to your colleagues.
Possibly. When we are talking about optimization tools, we have basically the advanced energy management system, which combines different parts of the system and it computes it. And of course, there is a thermal analysis. And I would say, and maybe you, Damian, could correct me because I am not the technical guy here, but in the advanced energy management system, PyTransit suite is going to use Transis to thermal modeling the solar thermal field. And then we can decide which flow and which power is the optimal in combination with other sources that could be present in that system. For instance, a heat pump or a biomass boiler, etc., etc. So the answer is yes, there is a thermal analysis, and I would say that is done with PyTransis running Transis in its core. I don't know if, Damian, you want to add something about it, or maybe also Marnock, because at the end of the day, SUN-Peak is also analyzing the solar thermal field. In this case, just to analyze if the performance is correct, which is already a big asset. But in terms of optimizing, we will rely more on PyTransit suite.
Yes, I can also say a few words. I would say it depends. So if you focus, I mean, maybe, I don't know. Can we turn on the microphones as well because for me, like if you focus on the optimize, then I would also think, as you did, Xavi, that maybe it's kind of related to the AEMS. But there, I think PyTransit is used just to kind of validate the AEMS, but it has its own models. So, but it does do well there. I think, yeah. I'm not so familiar with the AEMS. Their optimization is linear, right? And I remember Dani saying maybe temperatures. Yeah. So I'm not 100% sure there. Yeah, but definitely on the planning side, if you mean like optimize during your planning as a human, then yes, the system is modeled thermally. So it's a yes there. If by flow you mean, for example, the flow in the collector field, this is not modeled. So like you can't use it to balance the flow in your collector field, for example. I don't think we have any tool that does that.
Yeah, but probably the question is like if I have a system with a solar thermal field and I have an additional source, how I can optimize the flow through my solar thermal system, then it will be using the advanced energy management system. And as you rightly said, it's not using PyTransit suite, but other linear optimizers that will run, of course, in combination with some physical models about what's happening in the solar thermal field, which also can be used in the design phase by how we are going to combine solar thermal with a heat pump or with a biomass boiler, how should be the sizes of those elements depending on the prices of electricity, depending on the sun available on site, etc., etc. These also, they will use the same optimizers that will, of course, work together with thermal analysis. To close this question, neither Damian nor myself, we are the developers of the optimizers. That's why our answer was slightly incomplete, but for sure we know that there is a thermal analysis performed.
Thank you both for your attempt to address this question. Of course, you can follow up via the chat box needed or later after the webinar. Now, there is another question, Javier, addressed to you regarding your slide number 10. In this slide, it is mentioned that the LCA and LCC, the software uses primary from real-life monitoring and secondary data coming from APIs. Can you elaborate on the sources from the secondary data? Thank you in advance.
Yes. This tool is developed by Thirth, our colleagues from Greece, and basically it computes some KPIs concerning a life cycle cost analysis and environmental KPIs, and they use different kind of data. When we say real-time data, IoT data, we are talking about, let's say, for instance, an energy meter that is connected to the solar field, for instance, and is uploading to the cloud or to the software every 15 minutes the amount of energy that is being circulated through the solar thermal field. This would be a primary data or IoT data. And the second kind of data, my colleagues from third would most likely, for sure, not most likely, answer it with more detail, but I'm pretty sure that is concerning data related to, for instance, the components that have been used to build the system, how many kilograms of iron are in that data sheet, how many kilograms of glass to compute the impact of the installation on environmental KPIs. Those data, they will be stored in databases, not necessarily from in Verify, but maybe in another data source of the DS suite, and then this data will be transferred through APIs from that database to the source code of Verify to compute the impact of the installation. So I don't know if this explains the different data that is used to compute those KPIs that Verify will provide to the suite.
Thank you, Javier. I think you have thoroughly covered this topic. There is another question in the chat box, but before jumping into that one, and since we have 8 more minutes, I would like to ask one more question to Javier, because this is very relevant. In your project, you cover different applications from pulp and paper to district heating and food processing. My question is, what do you expect to learn from these diverse applications that would make the platform, the DIGISOLAR platform, scalable beyond what you foresee in the demo sites? If you can already share some insights about these expectations from the different applications you consider in the project.
I don't know if Marnok want to say something about this, or do you want me to answer? We expect to understand different behaviors about demands related to heating demands, related to different applications. And of course, our tools will be used in the same way, but they will, let's say, be optimized, or we will see the power of the tools by specifically using it in different applications. So because we can have batch processes in some of them, so maybe storage systems will make more sense in batch processes. So when we are producing some hours of the day, district heatings have a different nature, so they might also be combined with heat pumps, and then also our digital tools will help to both design better these systems according to these different demands and operate those systems in a different way. And additionally, we also expect some different kind of faults in different kind of applications because of the different nature of the applications. So we will stress a little bit our fault detection and diagnosis module depending on which kind of application we are using. Definitely, we are hoping, and we are sure we are going to learn a lot about our demonstration sites, and we are going to most likely improve a lot our softwares after the feedback we get from them.
So I guess you expect to have a wide geographical coverage, different temperature levels needed in the industrial processes, and at the end demonstrate that all these solutions are applicable across Europe.
Exactly. Ultimately, what we want with DIGISOLAR is to increase the share of solar thermal in industry and, of course, in district heating. That's the main point, especially in industry. Solar thermal has not been widely adopted in Europe and in the world because of several issues that we think that we can improve by doing two things: hybridizing with other renewables, as we asked at the beginning of the talk, and by using digital tools, as also Marcelino said, that help us operate and diagnose and maintain in a better way those systems. So these two vectors, they should help us to accelerate or foster, better said, the adoption of solar thermal throughout Europe, by, of course, in different applications with different temperatures, with different mixing of hybrid sources, and all this complexity helped out thanks to the DS suite.
Great. Thanks, Javier. So I think we can jump to the last question. It's addressed to both projects. Maybe we could start with Marcelino. What is the most critical barrier for the large-scale deployment of your tools from the demonstrators to stakeholders outside your projects?
Well, I think the barriers are some cases are not technical. I mean, in the commercial plants, and this is you have to validate the plants in commercial plants. You need to make agreements with the owners. The owners usually are not the same people that are the people that make the promotion. In our case, we have Cox Energy and Acciona. But the plants that they promote and they are partially owned by them are not totally owned by them. So it took to us a long time and a lot of agreements to really make the agreement to have and to test the tools in their plants. They want to do it because they really, I mean, the technical people from Acciona and from Cox, they really believe in the tools. They really are confident that we are going to succeed. But once the plants are up and running, you have banks that put the money in the project, the kind of thing. So to me, the difficulty is that. For the new ones in the future, I think it's going to be easy. Once it's demonstrated, I hope that the tools will be adopted while the contract while building the plants. But in those that are already up and running, the main difficulty is that you have contact, you have banks, you have many people involved. That you need the permitting of all these people to allow you to make some proof in the plants. Okay.
Indeed. I couldn't agree more. Thank you, Marcelino. Javier, if you want to say a few words about your views on the critical barriers for the large-scale deployment of digital tools in solar thermal installations.
In my opinion, the big barriers are still there for the adoption of solar thermal in some cases, which is economical sometimes, because still, unfortunately, fossil fuels are still cheap. Even we have this kind of macroeconomic oscillations due to wars and shortage in providers. But still, this is one of the challenges. So what we think is that the tools themselves, they are going to help make these barriers smaller in the case of solar thermal, because CSP, there are installations that due to scale, they need to be large or very large because they require very big investments. Solar thermal can be very, very small, can power up even domestic water system for a building, so it can be very reduced amount of square meters and then can become very, very, very large. So barriers would be, to me, in my opinion, is they are more basically on the cost and the cost of the levelized cost of heat that we can produce with solar thermal, which needs to be slightly reduced, and we believe that the tools can help make this levelized cost of heating smaller. So to summary for my answer would be like that we think that the barriers of the tools are the barriers of the market for solar thermal, and that our tools will make these barriers smaller and foster the adoption of solar thermal.
I want to add something else. Is in my view, I think that in one or another way, I'm sure 100%, I'm not talking about my tools or their tools or whatever tools, digital tools are going to be implemented in solar for sure. Could be the tools that are developing in one project or in the other, or other people making new tools. But they are going to be implemented for sure. The difficulties here is if we are going to reach what the market needs in terms of cost or other things from other issues. But the digital tools, artificial intelligence, in the same way that we are having all this in our lives, even if you don't want it, you're going to have it. Then the same is going to happen with solar.
It's true, and I think that your presentation also made a very clear point about that there is room to improve the operation of those systems. It doesn't matter if it's CSP or if it's solar thermal, they can run better, they can produce more energy, they can be stored for longer times. So we can improve some KPIs that are critical for the market to adopt that technology. And digital tools are going to be part of that improvement. That's for sure, because it's happening in all aspects of life, technical or not. So we also can see, because we are developing the tools, that there is a room for improvement, to be more efficient, to be more less expensive, and to be more reliable. And this is what we think that we have to do, because the market will welcome those digital tools, because it will make it more profitable.
Could I add to that maybe? Also, because it also addresses your previous question, is the difficulty we have in solar thermal in particular, especially, and I imagine this is maybe somewhat true for CSP as well, is the diversity of applications and the diversity of design and implementation of the project. So PV, for example, has it very easy. It's very standardized. Solar thermal generally is not, which is why it's important for us to have many different applications in our demonstrators. And that way we can build our tools to address as many possible use cases and as many possible configurations of installation as possible. And that is really the critical thing, and that is a barrier for us, but that is also how we address the barriers in this project, is that we make sure that the tools we build are actually easily deployable for all of the relevant installations. And we're very well positioned to do that with the diversity of demonstrators and sectors that those demonstrators are in as well.
Yeah. Just one thing is, I very much agree with what you said, but I will explain this in another way. From the point of view of physics, let's say photovoltaics is very complex and solar thermal is very easy. But for the point of view of the engineering, photovoltaics, all the complexity is within the panel. So in the end, you can have you don't need extraordinary knowledge to build up a solar PV plant, but on the contrary, you need an extraordinary knowledge to build up a solar thermal plant. So I believe with digitalization, we can, let's say, somehow wrap up everything and put all the complexity out of the people that have to take the decision. The complexity will be handled by artificial intelligence, advanced monitoring, and all these things. And then probably we can make the life of the EPC constructor more easy by using digital tools, artificial intelligence, and so on. And this is the challenge that we have in front of us.
Exactly. The answer to the barriers and how we remove them for our tools is the same as for our technologies. We have to hide that complexity from the end decision makers and make everything as standardized and as easy from their perspective as we can. That's the...
Okay, thank you very much for this interaction, and I apologize to Celine that we took longer than what we had originally scheduled, but I think that this Q&A that involved into a discussion session creates commitment or expectations for similar webinars in the future. And I will close with this and give the floor back to you for the closing session. Thank you very much, all of you, for the interaction.
Yes, thank you everyone for for joining this meeting. Yes, unfortunately, we don't have time to answer all the questions and also using the Slido that we have prepared. But we hope that you got a lot of information of the projects. And for your information, so this webinar officially starts the collaboration between the two projects, DIGISOLAR and SUN-DT. And of course, we will organize future joint webinar and also joint activities in the coming months and years. So you will have the opportunity to discuss again with all the partners from our projects. We will also invite you, I will just quickly share my screen so that you can see the website of our project. So I will just invite you to visit the websites of the DIGISOLAR and SUN-DT project and also the social media channels so that you can be kept informed about the activities of the projects. So I will now close the webinar. So thank you again, everybody, for your participation. And yes, we hope to see you again in future activities.